Welcome, everyone. I thought I'd get everyone jumping onto the Menti to introduce yourself, name, organization, and your best guess at what dark matter is, if you've got a guess.
Okay.
So you just hit the go to menti.com or use a QR code and you can log in. We've got a couple of other things on the Menti, which is why I've got it up there. A few polls we may want to take. Maybe the dark matter questions freaked everyone out. So you can just put your name and organization up there and anything else that's interesting. Okay, it says people have responded, but I don't see anything on the screen. Oh, they're starting to come up. Thanks. Is he? Well, of course, no one knows. But that's why we've got to make a guess. We'll give a few minutes for everyone to roll in, introduce yourselves. Feel free to introduce yourselves verbally or make any announcements. Anything that's interesting. If you're first time here, introduce your interest. Maybe while we're doing that, I'll just give a brief update. As this is the Australian LCA Society's monthly webinar. Yeah, I think it's from another dimension as well, David. I think that's a good answer. I reckon it's there, but it's in a fourth or fifth dimension that we can't
Yep.
grapple with. But I still, that doesn't really help very much to visualize it. Um, Still got people coming in, so we'll wait a little bit longer. But I was going to just give a brief update for people who are interested in the progress of ALCAS joining the Environment Institute of Australia and New Zealand. It's progressing. We sort of made our decisions. So we have now been waiting for the Environment Institute of Australia and New Zealand to do its due diligence and go to its board to make its decision that yes, they would like to have us as part of their organisation as a subgroup. And so we're almost through that, I believe. They've got a board meeting next week. And from that point on, we will actually then start negotiating the mechanics of how we will incorporate ourselves with them. So we haven't progressed any of the mechanics on membership transfer, what will happen with the certification schemes and things like that. So just sort of give people a brief update on that before we get into today's topic. Okay. No other announcements. No more guesses on dark matter. Okay. We're going to move to the uh, next thing. So today we're going to talk about landfill. Can't remember. It came up during the week, and I was like, oh, it's like, oh, the problem of modeling landfill and the decisions to make. So I thought I'd share the angst with everyone here and see if we can progress our consensus about what we should be doing with LCA questions around landfill and some ground that's well trodden, but still the answers are still hang in the air a little bit. But I thought the first thing when I was like, when you look at landfill, it's such an awful name. So I thought what we want is I want people to suggest better names for landfill. Um, Imagine you're an advertising agency and you've been asked to improve the the brand of landfill, and they're like, man, it's just like landfill. Like it's such a bad name. So is there anything uh better we could call it? Turn to earth. It's nice, isn't it? Resource potential. Residual waste. Residual dump. Resource amalgamation. Rubbish pile. Cool. Well, it's clear that we are great scientists and maybe not the best brand people. I don't see anything jumping out that we're going to make a fortune on. But it sort of brings the point, I think, that um, we sort of don't like landfill, and in our models, you don't want that to sort of, there's always, I think there's this organizational thing where we want landfill not to look good, and whatever the other alternatives to is likely to be better. Yet it remains the main form of waste disposal globally, and particularly in Australia. And so it's interesting in its dominance there. Okay, so I'm just looking. I think we're going to. Have we got anyone want to vote on what they think is the best option that we're going to put forward to the client? Land creation. That's positive. I do like Return to Earth. It's got a nice spin to it. Waste of money. Yeah, well, they're pretty cheap. Okay, let's go. The third of these questions that I want to do run through the Menti is when we think about landfill, what do we think are the, oops, sorry, I got a typo there. What are the biggest, what's the biggest problem? If we had to rank the reason we think landfills are a waste of money and not very good and need rebranding, um, in order of priority, what would you say are let's order those five. I think can you move them around or something? Or you have to enter a ranking. I suppose it matters. Like if you live next to it, you probably rank these differently than if you are thinking of it from a life cycle perspective across the whole product supply chain. And you get the sort of connection with the occupation of space-time. I've got very quantum physics on us today with dark matter and space-time. They do occupy a volume of space for an amount of time. So that's okay. There's no right answer to this. I don't have um, a measure. We could do if we were to maybe look at our landfill total landfill normalization. If we had the landfill of everything and do this LCA of it, and use maybe one of the weighted indicators, might be able to get a sense of the whether toxicity or greenhouse gases are ranking. They're the two that are, and maybe the land use. I imagine the land use is definitely small because they tends to occupy not a huge amount of space compared to other land uses. So I get that one's pretty makes sense. I would have thought the resource stagnation, if you were evaluating the resource benefits and the fossil and mineral resource benefits in things thrown into the landfill and their opportunity cost, that might outweigh the others. But and the soil water contamination is an interesting one because that really relates to how well do our methods currently measure that soil and water contamination issues coming out of landfill. Great, thank you very much. I think we'll leave the Menti there and I will switch screens. Um, uh, oh, sorry, there were responses in the chat. I didn't see the chat. Okay. And, and to the 80s kid, Andrew, it's waste and like landfill is sort of like climate change before we had climate change. Before climate change, your pretty much your focus, a lot of the focus of the environment industry was around waste prevention, pollution control. The first life cycle inventory database was developed by RMIT in Australia, by RMIT with the Cooperative Research Centre for Waste Management and Pollution Control. How sort of end of pipe name is that? They didn't go to the rebranding school for naming. So it's funny that waste has sort of been pushed aside a little bit by the dominance of greenhouse gas related issues. Okay. um, as usual, I'm not an expert in landfills and waste management, but I'll give some perspectives from the life cycle thing. So please feel free to jump in and add as we go. Just I'm also not an expert in using Zoom. It's a bit of a cow of a thing with 4 screens. Jimmy should disconnect some screens for this. Okay. This is Darebin Parklands. Anyone who lives in Melbourne, just around behind High Street, Northcote, Preston sort of way. Used to be a landfill a long time ago. Not sure whether it would have been filled with municipal solid waste at the time, whether it was more construction waste, but it was a landfill. And so we do get the space back at some time down the track. I thought one of the open questions is, is this landfill is it better or worse? Is it increasing or decreasing? It's still the dominant disposal pathway waste to energy is emerging in a couple. Recycling is strong, you would say, in the construction sector and others, but still, overall, the waste bin is still often heavier than the recycling bin. Um, and it has been this inspiration for the circular economy. So, looking at some of these issues around, is it a greenhouse problem? Where should it rate in the greenhouse gas stakes? And so, this is the national carbon balance from the National Inventory Report, and you do see some interesting things. They're relatively small, but you can see 5A down in the lower part for the detail of emission uses. We have landfill of non-harvested wood products. Waste disposal landfill is a little brown blob, which is quite large. Then we've got landfill of non-harvested wood products, landfills of harvested wood products. And then we've got in green stocks and sequestrations coming from harvested wood product stocks. That's in the economy. And then way down the bottom, product, harvested wood products waste in landfill. So landfill is both a emitter and a stock of carbon, according to our national accounts. And so they do count the storage of carbon associated with harvested wood product materials, i.e., biogenic materials. So from all of that, waste is nowhere a competitor with fossil fuels, and you'd say it's not a competitor against things like the transport sector and the building sector for greenhouse gas emissions, but it's not irrelevant. It's in that sort of 5% sort of range where there's a lot to be done there, and that's still a lot of emissions on a national account. Is waste going, are we improving our disposal rates? And so this is the percentage of disposal by over 4 time periods by state. And we can see that we're really, there's a bit of up and down, but actually there's not a huge amount of improvement at this point. I would have thought over this time period, maybe if we look at the improvements in energy efficiency over this time, improvements in greenhouse gas performance, improvements in the grid, that all be trending much more substantially down than what we're getting in terms of percentage removed from landfill. So obviously a bit of the data for NT was a little bit tricky. But everyone else, there seemed to be just that WA did a bit back in 2014 to 2018 and has sort of leveled out. The big ones of New South Wales, Victoria are a bit up and down. So yeah, that's not a great story. Of course, that doesn't tell you very much about the fractions and what's actually going into landfill. And of course, we know that landfilling of sand and brick and rubble and things like that has much less detrimental impact than landfilling of organic and toxic materials. So the quantities of the types of materials really matter. So if we look at organic waste to landfill, there is a 2030 target to get it down to 2.87 megatons annually. It's part of I think the National Waste Strategy. And I live in inner Melbourne, and we only just got food and organics collection like last year, sometime last year, early last year. And so I would have thought that that with food and organics collection and things, that this would be trending way down. I suppose we're starting to see that trend in that third dot point where it's turned a corner, but it's got a way to go to get down to our target line. So I think getting that organic material, um, the material that most people think it's fine to send to landfill because, well, it's not plastic because it's, you don't want to send plastic to landfill because that might sit there for a million years. And so a lot of people have been happy sending organic material to landfill, thinking that it's organic and it's like, what brand did we give it? It was a return to earth. Some people think of landfill as return to earth, and so that's fine for organic material. And we know from a climate change perspective that that's not the case. Um, and one other interesting one. So obviously, paper products play a important role in landfill, both storing carbon, also emitting carbon. Uh, and we seem to have turned around in the last 15 years, removing paper from landfill. Huge drop between 2000 and was it six through to 2018, and now we've sort of leveled out now. Um, Part of that is a big drop in paper consumption, but in fact, you can see that paper recycling has maintained its height. So it's an interesting thing that we've clearly paper and paper recycling, the paper industry have done well to get those materials out of landfill. So it's a bit of a mixed picture there, isn't it? We're not necessarily reducing landfill, but we have got, looks like organics are starting to come down. Paper products have definitely come down over time. Then shifting, sort of related to that, but shifting to what's happening with methane and methane capture in landfill. And this is from the national accounts, as is the previous graph was from the National Inventory Report for greenhouse gases. Here we've got that, over time we have recovered more and more methane, but pretty flattened out over the last 10 years. I would have expected that to be going up, but we seem pretty flat. That could be, I don't know if there's any landfill experts on the call. Maybe that's because we don't build that many new landfills, and so the technology we've got, and I think these numbers represent the methane emitted last year. And of course, the methane emitted last year is from waste and engineering that happened over the last 30, 50 years, probably 30 years. And so maybe we're not going to see much technological change because we're just not building, we're not replacing the old landfills with new landfills. Uh, and so maybe that's why that's sort of flattened out. But sort of interesting that it has. And that the methane emissions from landfill haven't really shifted for the last 10 years. And we would expect like all that extra paper that hasn't gone into landfill, of course, it wouldn't degrade until the next 20 years, in terms of it getting into its main gas generation phase. Interestingly, for the methods for recovering methane from landfill, where you could generate greenhouse gas credits for capturing additional gas at landfill and combusting it for power generation. And that the baseline assumption was that the 30% of methane that a landfill baseline was set at 30%. And so the first 30% you couldn't claim as being additional methane captured because it was already being captured. And the maximum they allow you to claim as capturing from a landfill is, I think, 70 or 75%. So in terms of the regulation for using landfill gas capture as a carbon offset, they sort of set the default baseline at about 30%, and they set the maximum possible at 70%. Now, we don't have a percentage here. I think the percentage is about 43%. If you go and look at the national accounts and the yeah, if you look at the ratio between the recovered and the generated, it's about 43%. And yeah, and then stuck around there for the last few years. So some of the understanding some of the greenhouse gas flows associated with landfills, we have carbon being absorbed from the atmosphere in biogenic materials, or what the national accounts called harvested wood products. Uh, that material then becomes a waste, either construction waste or paper waste or some form of waste material, um, enters the landfill as a carbon store. We then have some level of waste degradation leading to biogas formation. The biogas includes CO2, biogenic CO2 coming back, fugitive methane coming out, and that's then you'll have some of that will be released to the air, some of it will be oxidized because it goes through the landfill cap. It somehow oxidizes the methane back to CO2. So that then releases biogenic CO2 to air. And of course, we capture some methane, produce electricity, and that gives us avoided electricity credits because it generates electricity, which releases biogenic carbon dioxide to the air. One interesting assumption I'll look at a little further down the track is all of this methane biogenic, and is all the CO2 biogenic coming out of the landfill? Is there a situation where fossil-based carbon will come out and be a fraction of the biogas? So that's just a little bit about those dynamics. So let's jump into the LCA issues. So the first big one is carbon stored in landfill. There is a fraction of carbon stored in the landfill that doesn't get released. In the first 100 years, that fraction will be 90% for wood products. It can be, I think the DOC-F for paper is 27% coming out, so it's 73% for some paper products. And so it's a significant amount of credit. Just to have a look at this is greenhouse gas emissions with and without counting the storage of carbon in the landfill. And so and this includes methane emissions and things. And so you can see for wood products, you go from being a net negative, a net sink, accounting for the bit of methane, to being from net emitter to a net sink. For newsprint, similarly, because there's lignin on the paper and it degrades less than other papers. Office paper, highly cellulosic materials tend to have much higher degradation rates, and so you get those different effects. The other thing that affects this is moisture. So, why is food different to paper? Because it's wet, and so half of what you put in is actually moisture and doesn't count. So it's a substantial store, but it's a store in a sense of, well, in 100 years and in computer modeling and lab modeling, we can say it's stored. The bigger question is it stored for really long time frames? If we stretch it out to 500 years, 1,000 years, or as the Swiss do for 66,000 years, would you still be counting it? And should we be counting this store if it's not guaranteed to be stored forever? If it is there, and should we count it? Should we give a credit? And who do we give the credit to? So there's a carbon store. Typically, currently in an LCA, the credit for that storing of carbon would go to the product system that was made out of the carbonaceous product that went to landfill. So if I'm a book, the book, and I get thrown into landfill, the book would get a credit for some carbon storage. Or if I'm a piece of pine framing, and I get thrown into landfill, it's the pine framing, pine industry, the building that would get the credit. Uh, I'm not sure if is that consistent with our other. That's sort of there is a connection. If we build more pine houses and we throw more wood into landfill, does the store increase? And generally, yes. So there is a connection between, uh, you know, do more of it, does it continue to happen? I don't think, I think at the national accounts level, we count this carbon store in landfill. So from a country level, the country takes the benefit of it. It comes off of our national accounts. From In most LCAs, though, and Andrew, more others might chip in. If you're doing a LCA using the EN 15804 standard EPDs, you are not allowed to count this storage of carbon credit in landfill. Whatever gets put into the landfill, you have to assume is 100% oxidized, even if it isn't. So you essentially have to add a pulse of CO2, biogenic CO2, to the atmosphere equal to the carbon that enters the landfill. Is that correct?
Oh, can I talk?
Yep, you can.
Oh,
I don't know, but you can
um,
a bit. Yep.
yep. Andrew Moore here from, where am I? Lifecycle Logic, APD Australasia. Yes, Tim, you're correct. It needs to be
Right.
released or accounted for as a virtual release in the end of life module.
Right.
So if you're doing an EPD, please don't use any other words. Please use the specific words virtual release.
Oh, okay. Cool.
And I'll send
Um,
you all the link. There is an appendix in the product category rules for building construction products that goes through all of this, because for everyone it's a nightmare. So here's the link. And I think it's appendix 3.
right. This goes. There was a text. I'm not sure if it's in 14067 or somewhere else where the CO2 from a harvested biogenic materials was deemed to actually be emitted at the point of harvest. So that has changed, because in that case, you'd count it as soon as you harvest a tree, you would count all the CO2 is going to be in the atmosphere at some point, and therefore you would count it there. But now it actually is counted as a virtual emission at the end of life, at least in that system.
Um,
Could you remind me about EPD? What does that stand for? I've forgotten.
Andrew, you're the
and
best one.
Environmental Product Declaration.
And so these are highly structured, highly ordered LCAs with lots of rules, as opposed to, a lot of the LCA do where we make our best decisions. Yeah.
Yeah, so what you were saying before sometimes still does apply. So if you're only doing an EPD that covers cradle to gate, so that's like raw material extraction, production, getting it to your manufacturer's gate, then previously you could balance out the biogenic carbon that would be released later on. You balance it in A1 to A3.
Right.
So yeah, again, refer to the product category rules link
Yeah.
that I sent.
Yeah. So that's where they're randomly penalizing. We're saying, and there's no justification, I assume, as to why they do that. It's just either they don't believe it's going to be stored forever, or they don't want to give landfill a step up credit, just because we don't like landfills and they're branded badly.
Yeah, it was a European sort of driven thing. I mean, it is a bit of a perverse incentive to have a carbon credit for basically growing trees and then stick it in a landfill. So
There's
yeah.
There's two instances where it becomes sort of inconsistent. Is that if we combust the material for energy, we don't count the emitted carbon from it as fossil carbon. So by counting it in the not counting the storage, which would be a carbon store, when we count the emission, you do get the benefit of it being biogenic carbon emission, which is therefore carbon neutral and not counted as part of your emission profile. So waste to energy always seems a much better option for biogenic materials because of an accounting rule, not because it leads to a better greenhouse gas outcome. In fact, it puts more CO2 back into the atmosphere, but because of an accounting rule, because we don't like the counterfactual of landfill. So
yeah, I think some of that relates to the permanence.
Yeah.
Or the guaranteeing of the permanence for all the landfills and how they're managed and But yeah.
Yeah. So this is issue number one. We've got a software tool called PK for the packaging industry. In that, for years, we've not counted carbon store in landfill. I think the Circulus tool does a full carbon balance and it counts carbon entering landfill. If you have a full suite of the carbon indicators, carbon total, carbon fossil, carbon biogenic, carbon land use change, where they break them down often in EPDs, if you add them up, then I think it's not like counting a carbon store, but if you do a full carbon balance, there's just some carbon missing because unless you add this virtual carbon emission in an EPD, but in a normal LCA, you wouldn't add that virtual carbon emission. It makes no sense. Okay, that's thorny issue number one. Thorny issue number two is the methane release and what is captured. So the 43% I mentioned before is an historic number based on all the existing landfills for a whole bunch of product systems that no longer exist. So it's sort of like an answer for what is the methane how much methane is going to be captured from my product system that I'm designing now if it goes to landfill. We really use this historic number that is really based on all the landfills of Australia where they sit. Happens to sit around 40. Hopefully it's 42% now. That's 42 is a good LCA number. We always thought it's around 50% we used before. We had a number from the national accounts. It was a number that was thrown about a lot. And of course, we know it can go as low as 30 on a normal landfill and as high as 70% capture. Of course, it can be zero if you're smaller rural landfills where there's no gas capture. Then you can have 100% of the emission, of course, going to atmosphere. So there's one question around, do we use that historic basis? Do we say, well, basically anything we make now, any timber product we make now will go into a landfill that's licensed this year, or actually it won't be licensed for another 50 years. And that licensing and that landfill will be a much better landfill than the average of the historic landfills. So you could say, well, we're only going to build really good landfills from here on. And of course, I'll have 70, 80, 90% gas capture. So would be a different question, different way to look at the methane. When you capture the methane and you generate energy, there is a question about who gets the benefit of the energy credits and who gets the impacts of the methane emissions. So currently in AusLCI, our National Australian Lifecycle Inventory database, the product system that supplies the material to be sent to landfill, that degrades, generates the emissions, gets both the emissions of methane that escape and are not captured, and it gets the emissions and credits from burning energy to create electricity to that are linked to its product system. So essentially everything goes back, credits and emissions, to the product that was sent to landfill. In the same way before, when we were talking about carbon storage, it would be the building that gets the carbon credit. Again, the EPD EN 15804 community have a different view of that, and the energy credits are given to the electricity system and not to the energy production system. So we need to remove any energy credits, any avoided energy benefits. So this would be a fossil energy credit going back to the building for sending its nice degradable material to landfill. And it actually goes, the credit goes to the electricity production system. Yet the emissions from sending things to landfill still, so the methane that isn't captured, you have to cop. For the methane that is captured and turned into energy, you don't get a benefit for. That gets given to the electricity system. Now, part of that could be linked to the fact that a lot of this energy has actually been generated, is generating ACCUs, or carbon credits that are essentially being sold. And so the benefits of the electricity benefits have actually been sold to the carbon market. And so that electricity, any goodness, has been sold off and bought by somebody else. So, you maybe no longer own it. But from a pure LCA perspective, you would typically send it back to the existing system. But I think in the in 15804 version of the Oz LCI database, we actually remove energy credits from incineration. And we do take, when we have the production of electricity from landfill gas, does get the gas for free in both the normal Oz LCI and the EN 15804 Oz LCI. So in a way, we do double count the credit for that biogenic gas. So it's a very small overlap, but it is essentially a double count. So, okay. Big issue number 3, plastics. So there are the assumptions on degradation of plastics, and what do they degrade to? So we have some that may degrade to carbon dioxide or methane, to biogas. So if you've got a pure starch-based plastic, it could degrade to that. If we look at some of the, I'll mention shortly a landfill LCA model developed by a guy named Gabor Docker from Switzerland. In that model, plastics are 100% of plastics entering landfill will be released as particulate matter sometime over the next 60,000 years. And so it has this huge particulate matter emission because plastic was sent to landfill. I'd find that a bit of a stretch, but that's what they model them as, particulate matter. Maybe if Gabor, or in his next one, because the microplastics indicators didn't exist previous to the latest update of his landfill model, he might emit them as microplastics, assuming that everything in the landfill will end up in the environment in some way. Therefore, what would be released from plastics breaking down in landfill or fragmenting would be microplastic particles. So currently I haven't seen any data on microplastics from landfills long term. We, in some of our studies, will model the microplastics from litter associated with recycling and landfill systems. So there's always a small amount that gets lost along the way, but we haven't got any models that represent an emission of microplastics from a landfill. And we then have, so that's sort of around degradation. What's it going to degrade into, and how do we treat that? What's happening to that? Do we could carbon store? Sorry, I just wrote this before. Should we count the carbon store of landfill plastic? So we're putting fossil carbon from under the ground, and we use it in the economy, and then we put it into a landfill back under the ground. And we're not required by Andrew and the EPD scheme to count a virtual emission for that fossil carbon being put back into landfill, like we are with the biogenic material. So there's an inconsistency there that one point we have to add a virtual emission, yet for plastics, we can put them in there and there's no virtual emission. Of course, we assume the degradation rates of most plastics are very, very, very low. And just to look at those different scenarios, there are both fossil-based degradable and non-degradable plastics and biogenic-based non-degradable and degradable plastics. And so with plastics, we are putting a mixture of fossil and non-fossil materials into landfill, and they may or may not degrade. I have a table of our best estimates for different materials, predominantly plastics, what fraction of them is biogenic carbon, and what is the degradation over 100 years assumed for these materials. And surprisingly, so we all know packaging paper, 100% biogenic, 27% degradation. Okay, that's well understood. We'll use the same for bagasse pulp. For polylactic acid, PLA, a certified degradable polymer, degradation in landfill, 5%. Does not degrade in anaerobic environments. That shocked me. Starch biopolymer, 25%, which even I thought is low, given it's sort of starchy, and it's like saying rice is going to 25%, 100% biopolymer. Interestingly, then PBAT, polybutyl acetyl something or other, which is normally mixed in a sort of 50-50 mix with thermoplastic starch. So PBAT TPS is all the biobags, the Matabee, global Matabee compostable polymer, used in agricultural films, used in, I think, a lot of the biobags for bin bags and things like that. The PBAT fraction of that is 100% fossil. So we have our most common degradable polymer is half fossil material. And so the CO2 coming out of landfill from biogas and the methane would be proportionate would be fossil if it degraded. However, its degradation rate is set at 5% from best information we can get. And this data sort of compiled by one of our employees working out with the Bioplastic Centre at University of Queensland with Caitlin. So it's very hard to get accurate numbers of these. These are not numbers out of the National Inventory Report or anything. No one's making a judgment call on many of these biopolymers. I'll tell you what the number assumption is for paper, and the assumption for plastic is 0, but they don't go down to these specific nuanced polymers. So if you're modeling these materials, it's a lot of open questions. So I assume the EPD, if I put my starch-based plastic, I would need a virtual emission associated with it because it's biogenic material going in. If I put fossil material in, I don't have to do it. If I put half fossil, half non-fossil material, I assume I need a virtual emission for the biogenic bit, but not the non-biogenic bit. When we start trying to make random rules that are not based on what actually happens, this can be the tricky things you end up tied up in. Okay, the last one, I think it's the last one. I mentioned a comparison of waste to energy. The other one is toxic emissions. Okay, so we haven't really talked about fate modeling and toxics emissions. So the two issues here is one, can you do fate modeling of the, you have something toxic, you put it in landfill, and then at some point it may be emitted. And so that's a fate model of toxic emissions. But if you put paper into landfill and then leachate comes out of landfill, of course, there's nothing in the paper that ends up in the leachate. The leachate's from a mix of other things, but the paper or maybe the hamburger and the sludge and all the things combine into a big sort of, acidic soup that then maybe is able to leach toxic materials from other components in the landfill. If the landfill is half full of batteries, the batteries may not leach of themselves, but put in there with a bunch of hamburgers and paper and water and things would create an environment that would leach. So how do you allocate the toxic emissions? A fate model won't pick that up because you're not putting chrome into the landfill or lithium ions, but the product you put in there may actually interact with those materials. Typically, I think the model by Gabor. Gabor Docker is a very, very generous, very clever guy out of Zurich. He publishes lots of reports. Just go to docker.ch. He has a model for landfills, and he does all the landfill modeling for EcoInvent. They're these spreadsheet fate models. They are hideously complex. Typically have very long time frames and lots of interaction between the leachate and what happens to the leachate, whether it gets combusted or recycled, and how it gets disposed of. And so I refer you on wanting to go down the rabbit hole to check out Gabor's information. But one really interesting thing out of when we used this work on a project last year is stainless steel. 50% of stainless steel was degrading within the first 100 years. And there's a significant nickel emissions from the stainless steel degradation. And, that is yet, 27% of the paper's degrading. Like, I would never have put stainless steel as a risk factor for sending to landfill as a material. So, and it was from this model where we saw particulate matter arising from the disposal of plastics to landfill, because the plastics are assumed to end up fragmented and back into the environment at some point in the future, far in the future. So it, as we, I think, move forward and start to consider some of the waste to energy questions. So we've got a couple of waste to energy projects underway and planned, particularly in Victoria, and I think in WA you've got some. It will continue to be a question about the relative toxicity associated with landfilling of materials compared to burning and compared to other activities. And so it's in that context that maybe we need to go down this rabbit hole of, okay, what does really happen in terms of toxicity associated with landfills, and how does that relate to product policy? Or is that all about landfill policy, or should that really be relating to our product policy, and should we be considering that in our LCA studies? I think that's so I'm sorry there aren't more answers to those questions, but that's the current complexity of landfill modelling. In the AusLCI database, we only model the greenhouse gas consequences of landfill using the national accounts and things. We don't include all the toxicity modelling from Gabor's work. We probably should, but there's a bunch of work to go on there. So be careful if you really want to look at toxics, you've probably got to not use the AusLCI inventory numbers. Okay, any questions, comments?
I've got a quick comment before I've got to bounce.
Yep.
Yeah, thanks for the presentation. I think it's really good to highlight all the issues, and I think the answer is definitely ensuring that you transparently document all your assumptions in your LCA report. So whatever methodology you follow or approach, it's transparent, it's documented, can be taken into account when the reports are read and or verified.
Yep. And do your sensitivities, like test the sensitivity of, okay, if I did use that other thing, would it change my decision? Because often, yeah, okay, there is a whole bunch of complexity, but in fact, all versions of that complexity may not change your direction. And ultimately, that's, the decision making you're trying to deal with.
Yeah, people don't play with their models enough once they get them built. You definitely got to do the bash testing and make sure the policy decisions, if that's what you're doing it for, are valid.
Anyone else?
There is a question from Dinesh in the chat. It says, do you want me to read it? You find it there.
Yeah. Why did you say waste to energy gives biogenic emissions a free ride? Because if I send I suppose it's because the counterfactual is that landfill, I'm forced to emit it even though I don't. But when I send it to waste to energy, I get free emissions. I get emissions, biogenic emissions, not counted as fossil contributing. And so the benefit of the original biogenic absorption of the biomass is realized in a waste to energy plant, but it's not realized when you send it to landfill because they force you to re-emit it, even though it wasn't emitted. And so it sets up a biogenic materials infinitely better than fossil-based materials at in a waste to energy situation, but at a landfill situation, the biogenic materials are essentially penalized with this virtual emission, which isn't real. And so it's really when it's free compared to landfill. I'll put the Docker link in. Hold on. And I'm not sure I've met Gabor, but he is like, those movies where there's that person who just knows everything and the FBI employ them to, crack the code or something. If it was an LCA and there was a person, Gabor would be the person in that movie that, the FBI go to for solving things. He's extraordinarily, he's on the LCA list, often replies on there. His web page is like about 1989 or something. Or it's kept really plain, low design, high content material. If I can find the chat, I'll pop that link in the chat. Okay, it's 1 o'clock, so let's next month will be the other side of daylight saving. It will be the 15th of April. Any suggestions on topics? Always welcome. Have a good month, everyone, and we'll see you next time.